Welcome to the fourth video of structural drawing. In this video, we will discuss in detail about the sectional elevation of wall, in detail of seismic joint between column and bricks, and we'll also discuss about the different beams that has been used in this building. So let's start the sectional elevation of wall. As you can see, this is the brick wall, and these are the openings in the brick wall. It is the plinth beam, and this is the slab. It has a thickness of 6 inches, and here at the opening we have to provide this two vertical reinforcement on both sides, on this side left side and on this right side for this opening, and in this opening we have to also provide vertical bar in here and vertical bar here. These are the one bar only, one number 4 bars, vertical bars on both sides of the openings. We have to provide on the both sides of the opening. This is one number 4 bar on this side and one number 4 bar on this side, is same on this side of the opening and on this right side of the opening. And here, as you can see, this is a bar, two bars here we have to provide, two number 3 bars after 8 course of the brick masonry. So here, from here, the bar has been started and till here where is the end of the plinth beam and where the bricks ends. So we have to provide this bar, these here two bars after each eighth layer of the brick masonry, as we have provided here, and then after the eighth layer of the brick masonry we have provided another two number 3 bars here. This basically restrain the movement and load carrying capacity of the brick wall. So this was the sectional elevation of the wall. So now we have to discuss the detail of seismic joint between column and the brick wall. As you can see, this is the brick wall and here this is the column. So in normal cases, normally we in the RCC frame structure we provide the column, beam and slab, but here we have to first construct this brick wall and the column openings, and the opening part of the column should be left. Once the brick wall has been completed till this level, till the lintel beam level or the slab level, then we have to fill the column. But here once we constructing the brick wall, we have to provide these tooth type connections. So once we filling the column concrete will fill these gaps, these tooth type gaps, and will make a good bond between the bricks and the column concrete. And this makes the wall more integral and its capacity is also being increased in the earthquake because there is a mm, good bond between the columns and the bricks, so it will resist more load. And these are the stirrups that has been used in the columns, and these vertical lines indicates the main reinforcement of the column. And so this was about the detail of seismic joint between the column and brick wall. So now we will proceed to another structure drawings regarding the beams detail that has been used in this building, for which we have studied the different portions in the previous video. Now we proceed to the structural drawings of the beam. So this is the beam detail. So here we have to discuss about the beams detail. So here are three types of beams. This table shows the detail of the beam. So here is the name of the beams, and one is the CB1 means concealed beam. This is the beam B2, and this is the porch beam detail. And we will also discuss the long section detail of the plinth beam, and the cross section of the plinth beam we have discussed in the previous video. So the concealed beams, this is the beam sizes, and this is the mid-span bars at the bottom and top of beam. Here the extra bar details at the continuous support and at the edge support. And lastly, here it shows the detail of the stirrups in the column, in the beam. So this beam CB1 has a width of 9 inches and depth of 6 inches. The main reinforcement at the bottom of the beam we have to provide 3 number 4 bars, and at the top we have to provide 2 number 4 bars. And so it is not there is no extra bar provided at the supports. And stirrups that we have to provide in the concealed beam is number 3 bars at the rate 4 inches center to center, and this is the near supports up to L by 4. L is the length of the beam, and we have to divide by 4. The value came from this. We have to provide the reinforcement at this rate, and after this L by 4 length of the beam we have to provide the reinforcement of number 3 bars at the rate 8 inches center to center. And this shows the detail of the beam B2. The width of the beam B2 is 9 inches and its depth is 18 inches, and the reinforcement at the bottom, this is the mid span bar. At the bottom we have to provide 4 number 6 bar, and at the top we have to provide 2 number 6 bars, and the extra bar at the continuous support we have to provide 2 number 6 bar, and at the edge support we have to provide the 2 number 6 bars as the negative to counter the negative reinforcement. And the detail of the porch beam is that it has a width of 12 inches, thickness of means depth is 18 inches, and the bottom reinforcement at the mid span is 4 number 6 bar, and the top reinforcement is 2 number 6 bars, and the extra bar that we have to provide at the continuous support is 2 number 4 bars, and at the edge this is 2 number 4 bars, and the stirrup detail is same as per the concealed beam as per the beam B2. So now we have to proceed to the long section of the beam. So this is the long section of the beam, is of this main beam B2. Here this is the extra top bars, means this one, extra top bar at the edge. This is the edge, and this is the beam location at the supports which lies at this support the beam section. So here it is continuous, this beam. So at the edge, this is the main reinforcement at the top, and this is the top bars, and here this line from here to here, it is L by 4, and this is the top negative bars at the edge, and it has to be provided as 2 number 6 bar, this one from here to here, and this is the bottom bar. Here this is the main reinforcement at the bottom, and from here to here this is the length of this portion of the beam from here to here. So at the edge we have to take L by 4 to provide the top extra bar, and at the mid we have to, at the continuous support, we have to provide L length divided by 3 times L by 3, the length of the negative reinforcement at the top. So from here to here, it is the length of the beam divided by 3. This is the continuous support, and at the edge we have to provide is L length of beam divided by 4 as these to provide the negative reinforcement at the top, and this is the main reinforcement at the top. It is the continuous reinforcement, and on the right side of this continuous support, a continuous beam, here it is the also L by 3, but here we have to take the length of the beam on this side. This is the length of the beam L2 as L2, so we have to take its length divided by 3 to get the length of the negative reinforcement we provided in the top is extra reinforcement, and it is this one, 2 number 6 bar continuous support extra bars. So this is the extra bars at the continuous support as top reinforcement, and this is the top bar, main top bars, and this should be continuous along the length of the beam, and this is the main bottom bar, should be continuous along the length of the beam. So this was about the long section of the beam B2, and this is the typical long section of plain beam. The cross section of the plain beam we have discussed in the previous video, So in this video we have to discuss the long section of the plain beam. This is the plinth beam. This is the end of the plain beam at the edge. This is the plain beam is continuous here in this support, and the reinforcement detail is that here we have to provide the top extra bar by getting its length to divide the we will get the length of the top extra bar by dividing this length by 4, and at the continuous support at the continuous point we have to, here it is continuous, so here we have to take the length of the beam divided by 3 to get the length of the bars required to be provided at here as the top reinforcement. So these are the stirrups, this one, and it continues along the beam, and this is the main bars to be provided that has been provided at the bottom as 2 number 4 bar, and this is the top extra bar. It continues at the inner side, top side of the beam. This is the 2 number 4 bars, and this is the top main continuous bar. It should be provided along the long section of the beam as 2 number 4 bar. And here on this side of the support, the plane in the plain beam we have to provide the top extra bar at L by 3 till the length of L by 3, and this beam is continuous on this direction. This is the line of continuation, means the beam is continuous in this direction. So this was the long section detail of the plain beam. So now we have to proceed to the cross sections of the beam. So the cross section of this beam means the plain beam we have discussed in the previous video. Now we have to discuss the cross section of other beams. So this is the cross section of RCC lintel beam. So this is the lintel which we have to provide above all the windows, ventilators and doors. So the detail is that we have to provide 3 main bars at the bottom and 2 bars at the top, and this is the stirrups, and this is the brick wall above this lintel, and this is the cross section of interior beam. So this is a beam which is monolithic with this slab. So here this is the cross section of the inner beam, interior beam at the support. So at the support we have to provide also top extra bar to counter the negative reinforcement, to counter the negative bending moment that is produced at the support. So this is the top extra bar, these 2 bars, and these are the main top 2 bars, and at the bottom we have to provide these 3 as main reinforcement, and this is the stirrup, and this is the width of the beam, and this is the thickness of the slab, and this is the cross section of the beam, of the interior beam at the mid. So at the mid means here or here, the section of the beam, this one. So here there top bottom 3 main bars, and at the, as you know that at the mid means at the center of the beam there is more bending moment at the bottom side, positive bending moment here, like here. So uh, at the top there is no bending, means tension. So we have to not provide this extra bar. So this is not here, it is mistakenly put. We have to provide only these two main bars as a top. This is the thickness of the slab and this is the width of the beam, and it is monolithic with this slab. Now we have to proceed to the next cross section, which is the cross sectional detail of the exterior beam, means at the edge. Is the beam monolithic with the slab and it lies at the edge. So these are the three main bars at the bottom. This is the top bars. This is the thickness of the slab. This is the width of the beam, and this is the section of the uh, beam of the exterior beam at the mid. And at the mid we have to not provide the extra bar at the top, but at the support this is the cross section of the exterior beam at the support. So at the support we have to provide the top extra bar to counter the negative bending moment. So this is the top main bars and this is the top extra bars to, and this is the thickness of the slab and this is the width of the beam. It is monolithic with the slab. So this was all about the details of the beams of different beams that have been provided in this in the building that we have studied in the previous videos. And so now if you have any questions in this video, so you can comment in the comment section. So thank you for watching and please subscribe to my channel.